Hello everyone, this is Ramachandran, math tutor from onlinemathforall.com. In this video, we are going to see the third set of 10 hard SAT math problems with step-by-step solution for each problem. Let's go to the problems. 23 negative 7x equals to square root of 3k negative 2x. In the given equation, k is a constant. The equation has exactly one real solution. What is the value of 56 times k? Round your answer to the nearest tenth. Okay, now let me take the given equation as it is. That is 23 negative 7x equals to square root of 3k negative 2x. Now let's do some simplification in this equation. On the right side, we find square root over here. To get rid of the square root, we can square both sides of this equation. Okay, let me do it. When I square both sides of this equation, on the right side, the square root and square will cancel out. Now, to get the expansion of the square of the binomial over here, we can consider the algebraic identity, that is a negative b the whole square. Its expansion is a square negative 2ab positive b square. Okay, now let's compare this a negative b the whole square and this of 23 negative 7x whole square. At the place of a, we have 23. At the place of b, we have 7x. Now, to get the expansion of the square of the binomial over here, we can consider the trinomial a square negative 2ab positive b square. At the place of a, we have to write 23. At the place of b, we have to write 7x. Okay, now let me do it. That is 23 square negative 2 times for a, we have to write 23. For b, we have to write 7x. Positive for b square, we have to write 7x whole square. On the right side, we have 3k negative 2x. Okay, the value of this 23 square is 529, and when I multiply this to 23 and 7x, I am getting 322x. Okay, when I simplify this one 7x whole square, I am getting 49x square equals to 3k negative 2x. Now, let's rearrange the terms of this expression. That is, we can write x square term at first, then x term, then constant. We get 49x square negative 322x positive 529. We can write this stuff as it is, that is 3k negative 2x. Okay, now let me add 2x to both sides of this equation, and also let me subtract 3k from both sides of this equation. Okay, then this positive 3k negative 3k will cancel out, negative 2x positive 2x will cancel out. I am getting 49x square. When I combine these two x terms, I am getting negative 320x positive 529 negative 3k equals to 0. Here I am getting a quadratic equation in standard form, that is ax square positive bx positive c equals to 0. When we have a quadratic equation in standard form and the quadratic equation has only one real solution, then the value of the discriminant b square negative 4ac must be equal to 0. Here b is the coefficient of x, a is the coefficient of x square, and c is the constant term. And the question says that the given equation has exactly one real solution, and we have simplified this equation and we got a quadratic equation in standard form. Since the given equation has exactly one solution, for this quadratic equation also, the value of the discriminant b square into 4ac must be equal to 0. Okay, now let me consider the coefficient of x, that is a negative 320. So we have to plug in this negative 320 for b over here. Then I'm getting negative 320 the whole square negative 4 times a. A is the coefficient of x square. Here the coefficient of x square is 49. We can plug in 49 now for a. And c is a constant term. Here we have the constant term 529 negative 3k. Let me plug in. Then I'm getting 529 negative 3k. Equals to 0. The value of the discriminant for the equation we have over here is equal to 0 because the given equation has exactly one real solution. Okay, now we have to solve for k in this equation. Now let's do some simplification. Here the exponent is an even number, then this negative will become positive. When I evaluate this stuff, I am getting 2400. And we can multiply this 4 and 49. I am getting 196 times 529 negative 3k equals to 0. Now let me write this 1 and 2400. We can distribute this negative 196 to both the terms inside the parentheses. When I multiply this one and this one, I am getting negative 1 and 3684. Negative times negative is positive. 196 times 3k is 588k equals to 0. Now we can combine these two numbers. When I combine these two numbers, I am getting negative 1284. We can write the rest, that is a positive 588k equals to 0. Now let me add 1284 to both sides of this equation. Then this negative value, positive value will cancel out. I am getting 588k equals to 1284 on the right side. Let me divide both sides of this equation by 588. Let me do it on the right side. Then this 588 will cancel out. I am getting k equals to 1284 divided by 588. My aim is to get the value of 56k. Okay, now we can multiply both sides of this equation by 56 to get the value of 56k. Okay, let me do it. That is 56 times k equals to 56 times 1284 divided by 588. Okay, we can write 56k on the left side. On the right side, when I evaluate the value of this one, I am getting a very long decimal, that is 122.476190. It keeps going. Okay, according to the instruction, we have to round our answer to the nearest tenth. Okay, 56k. Okay, when I round this value to the nearest tenth, I am getting 122.5. Therefore, the value of 56k is about 122.5. For the function f, for each increase in the value of x by 1/4, the value of f of x increases by a factor of m. Which of the following equivalent forms displays m as a constant or coefficient? Okay, according to the information we have over here, we increase the value of x by 1/4. That is, x becomes x positive 1/4. Now, let me plug in this x positive 1/4 for x over here. Then I'm getting f of x positive 1/4. Okay, when x is increased by 1/4, the information says f of x increases by a factor of m. That is m times f of x. Okay, now what we have to do is in each of the answer choices, what I have to do is I have to plug in x positive 1/4 for x, and then I have to find the corresponding value of m. Once I get the value of m, I have to see the function in each answer choice where the value of m is displayed, either as a constant or coefficient. Now, let's check this stuff with the function in answer choice A. Okay, let me plug in x positive 1/4 for x over here. Then I'm getting f of x positive 1/4 equals to 13 times 100 raised to the power of 2 times. For this x also, we have to plug in x positive 1/4. Let me do it, x positive 1/4 over here. Okay, 13 times 100 raised to the power of, now we can distribute this 2 to this x and 1/4, then I'm getting 2x positive, 2 times 1/4 is 1/2. Okay, 13 times. Here, two values are added at the exponent. Whenever two values are added at the exponent, what we can do is we can take this base separately for each value and multiply the results. This is actually reverse of a product rule in exponents. Okay, let me write over here. That is 100 to the power of 2x times 100 to the power of 1/2. Here I have taken this base separately for each of these two values and added the results over here. Okay, 13 times 100 to the power of 2x. Okay, when I simplify this one, when I evaluate this one, I'm getting 10. Okay, we know that this is a stuff we have for f of x in answer choice A. Okay, when the value of x is increased by 1/4, the function f of x in answer choice A increases by a factor of 10. So that is the value of m over here is 10. Now we have to see whether this value 10 is displayed as a constant or coefficient over here. No, 10 is not displayed either as a constant or coefficient over here. So answer choice A is incorrect. Now let's check with the function f of x in answer choice B. That is, we have to plug in x positive 1/4 for x over here and here. Okay, now let me do it. That is f of x positive 1/4 equals to 13 times 1000 raised to the power of 2/7 to the power of 14/3 times x positive 1/4. Okay, now let's do some simplification. 13 times 1000 raised to the power of 2/7. Now we can distribute this 14/3 to this x and 1/4. Then I'm getting 14/3 times x. When I multiply this one and this one, I am getting 7/6 after simplification. Here, two values are added at the exponent. As we have done in answer choice A, we can take this base separately for each value and multiply the results. Then we get 13 times 1000 raised to the power of 2/7 to the power of 14/3 times x times 1000 to the power of 2/7 to the power of 7/6. Okay, now we can multiply these two exponents using the power of a power rule in exponents. Okay, now let's multiply 2/7 times 7/6. Here 7 will cancel out. 2 goes into 2 1 times and 2 goes into 6 3 times. I'm getting 1 over 3. Okay, when I multiply these two exponents, I'm getting 1 over 3. When I take this 1 over 3 as the exponent for this 1000, I am getting 10 as a result. That is 1000 to the power of 1 over 3 equals to, this 1000 can be written as a 10 to the third power whole to the power of 1 by 3. Okay, when I simplify this one, I'm getting 10. Okay, now let me write over here. That is 13 times 1000 raised to the power of 2 over 7 to the power of 14 over 3 times x, and the value of this one is just 10. We got this stuff for f of x over here in answer choice B, and here we have 10. So that is, when I increase the value of x by 1/4, the function f of x in answer choice B increases by a factor of 10. So this is the value of m, and we don't find this value 10 either as a constant or coefficient over here. So answer choice B is incorrect. Now let's check with the function f of x in answer choice C. Let's do the same thing. That is, x has to be replaced by x positive 1/4 in the function f of x over here. Then we get f of x positive 1/4 equals to 13 times 100,000. Let me write the stuff over here. Raised to the power of 16 over 5 to the power of 1 over 4 times x positive 1/4. Okay, now let's do some simplification. 13 times 100,000 raised to the power of 16 over 5. Now we can distribute this 1 over 4 to this x and 1/4. Then I'm getting 1 over 4 times x positive 1 over 16. Here two values are added at the exponent. Now we can take this base separately for each value and multiply the results as we have done in the two answer choices. 13 times 100,000 to the power of 16 over 5 raised to the power of 1/4 of x times 100,000 to the power of 16 over 5 to the power of 1 over 16. Okay, here we can multiply these two exponents. Okay, let me do it. 16 over 5 times 1 over 16. The 16 will cancel. I'm getting 1/5. So here we get the exponent 1/5 for this 100,000. And 100,000 can be written as 10 to the 5th power. So it has to be raised to the power of 1/5. So the simplification of this one is 10. That is, the value of this one is 10. Okay, now let me write the rest of the stuff as it is. It is 13 times 100,000 to the power of 16 over 5 to the power of 1/4 of x. Okay, already we got the value of this one as 10. We have this stuff for f of x in answer choice C. So here, when I increase the value of x by 1/4, f of x increases by a factor of 10. Actually, this is a value of m, and I don't see this value 10 either as a constant or coefficient over here. So answer choice C is incorrect. Now let's check with the function f of x in D. That is, we have to plug in this x positive 1/4 for x over here and here. Okay, let me do it. That is, f of x positive 1/4 equals to 13 times 10 to the power of 2 over 3 to the power of 6 times x positive 1/4. Okay, here 13 times 10 to the power of 2 over 3. Now we can distribute this 6 to this x and 1/4. Then I'm getting 6x positive. 6 times 1/4 is 6 over 4, or in simplified form it's 3 over 2. Okay, 13 times 10 to the power of 2 over 3 to the power of 6x times 10 to the power of 2 over 3 to the power of 3 over 2. Okay, here 13 times 10 to the power of 2 over 3 to the power of 6x. Okay, when I multiply this 2 over 3 and 3 over 2, that is equal to 1. That is, we get 10 to the first power, that is 10. We have this stuff for f of x over here in answer choice D. When I increase the value of x by 1/4, the function f of x in answer choice D increases by a factor of 10. That is, actually 10 is the value of m, and I see this 10 displayed as a constant over here in the function f of x in answer choice D. So the correct answer choice for this question is D. A juice mixture has a total volume of 125 liters and is 45% juice by volume. The mixture was created by mixing two different solutions, solution A and solution B. Solution A was 24% juice by volume. Solution B was at 64% juice by volume. The volume in liters of juice in solution A is equal to lowercase a. The volume in liters of juice in solution B is equal to lowercase b. The numbers A, B and P are all positive constants. If A is a P percentage less than B, what is the value of P? Round your answer to the nearest hundredth. Here we have a juice mixture which has a total volume of 125 liters, and this mixture was created by mixing two different solutions, solution A and solution B. Okay, now let me assume from solution A, it has been taken X number of liters. Then how many liters they would have taken from solution B? To know that, we have to subtract this X from the total volume 125. Then we get 125 negative X liters. Let me write over here. Okay, and also there is an information, solution A was 24% juice by volume. That is, in this X number of liters of solution A, 24% is juice. Now to find the number of liters of juice in this X liters of solution A, we have to calculate the 24% of this X. Okay, now let me write it over here, 24% of X. So this expression represents the number of liters of juice we have in solution A, that is given by the lowercase a according to the information we have. So we have A equals to 24% of X, and we can do some simplification over here. That is, we can convert this 24% to decimal, then I'm getting 0.24. And when we have OF of in math, it can be considered as multiplication, that is 0.24 times X. Now let me consider the other information, that is solution B was 64% juice. In this 125 negative X number of liters of solution B, 64% is juice. Now to find the number of liters of juice in this 125 negative X liters, we have to calculate 64% of this 125 negative X. Okay, let me write it over here, 64% of 125 negative X. This expression represents the number of liters of juice we have in solution B, that is given by the lowercase b according to the information we have over here. Then we have B equals to 64% of 125 negative X. And here we can write this 64% as a decimal, then we get 0.64. And for OF of, we can consider multiplication, then we have 0.64 times 125 negative X. Now let's consider the information we have over here, that is the juice mixture is of 45% juice by volume. That is, in this 125 liters of mixture, 45% is juice. Now to find the number of liters of juice in this 125 liters, I have to calculate 45% of this number. Okay, now let me do the calculation. That is 45% of 125, that is equal to, we can convert this one to decimal, then we get 0.45, and for OF of, we can consider multiplication, that is times 125. When I multiply these two values, I am getting 56.25. That is, in the mixture of 125 liters, 56.25 liters of juice we have. Okay, already we know that this lowercase a represents the number of liters of juice we have in solution A. This lowercase b represents the number of liters of juice we have in solution B. When we add them, that is equal to the number of liters of juice we have in the mixture. Just now we got it, that is 56.25 liters. Let me write it over here. Okay, already we got some stuff that is equal to A. Here it is 0.24x, and also for B we got the stuff that is over here. Now we can plug in this one and this one for A and B over here. Then we have 0.24x, a positive 0.64 times 125 negative x equals to 56.25. Now we have to solve for x in this equation. Okay, let me do it. 0.24x. We can distribute the 0.64 to this one and this one. Then I'm getting a positive 80 negative 0.64x equals to 56.25. Okay, now let's combine this positive 0.24x and negative 0.64x, and I'm getting negative 0.40x positive 80 equals to 56.25. Okay, now let me subtract 80 from both sides of this equation. Let me do it. When I do so, this positive 80, negative 80 will cancel out. Then I'm getting a negative 0.40x. On the right side, when I simplify, I am getting a negative 23.75. Okay, now let me divide both sides of this equation by negative 0.40. Let me do it. Here negative 0.40, negative 0.40 will cancel out. I'm getting x on the left side. Here this negative will cancel out. When I divide 23.75 by 0.40, I am getting 59.375. Now we can plug in this value for x over here to get the value of a. Okay, when I plug in 59.375 for x and it is multiplied by 0.24, I am getting 14.25. Okay, here I got the value of A, that is a 14.25. Now we can plug in this value for A over here and solve for B in this equation. When I do so, I am getting B equals to 42. Okay, now I got the values of the constants A and B. Now we can use this information, that is A is a P percentage less than B to find the value of P. Okay, now let me erase the stuff and continue the problem. Now let's write this statement as an equation, that is that means A is equal to P percentage less than, that means we have to subtract P from 100 percentage times this stuff, that is B. Okay, here for A we can plug in this value 14.25 equals to, and we can write this percentage as a fraction, then we get 100 negative P divided by 100 times, and for B we have the value 42. Okay, now we have to solve for P in this equation. I think for this one we can go with Desmos. Okay, now let's go to Desmos graphing calculator. Here we have Desmos graphing calculator, and I want to solve for P in this equation. Whenever I want to solve this kind of implicit equations using Desmos, at the place of the unknown, I have to use either X or Y, because Desmos will accept only X or Y as unknown. Okay, here the unknown is P. At the place of P, we have to use X or Y. If I use X at the place of P, then I have to consider the x-intercept of the graph to get the solution. In case I use Y at the place of P, I have to consider the y-intercept of the graph to get the solution. Okay, now let me give this equation as input. Over here, there is 14.25 equals to 100 negative. Instead of P, I am taking X times 42 divided by 100. Okay, here I got the graph of the given equation. The x-intercept over here is 66.07143, 0. Now at this x-intercept, I have to consider the x-coordinate over here. So this is the solution for this equation. I mean, this is the value of x in this equation. Actually, we have taken x instead of p. So we can consider this one as value for p. But according to the instruction, we have to round this value to the nearest hundredth. When I round this value to the nearest hundredth, I am getting 66.07. Therefore, the value of P is about 66.07. In triangle DEF, angle F is a right angle. Point Q lies on DE, point J lies on EF, and QJ is parallel to DF. If the length of EF is 45 units, the length of FJ is 24 units, and the area of triangle DEF is 630 square units. What is the perimeter of triangle QEJ in units? Okay, first let me draw a right triangle. Here I have drawn right triangle, and there is an information in triangle DEF, angle F is a right angle. So we have to mark the point F at right angle over here. And let me mark D over here and E over here. And we have the information that point Q lies on DF. Okay, now let me mark this point Q on the side D of the triangle at somewhere else over here. And we have the point G on the side EF of the triangle. Okay, on the side EF, let me mark J over here. Okay, and also there is an information QJ is parallel to DF. Okay, now let me connect the 2 points Q and J over here. And so the information says QJ is parallel to DF. Okay, already we know that this line segment DF is perpendicular to the line segment FE. Since this DF and QJ are parallel, then this QJ also must be perpendicular to this line segment FE. Then we'll have a right angle over here. Now let's consider the other information. The length of EF is 45 units. Okay, here we have EF, its length is 45 units, and the length of FJ is 24. Then what is the length of this JE? For that we have to subtract this 24 from this 45, then I'm getting a 21. In this figure, we have two right triangles. One is the bigger right triangle DEF over here and the smaller right triangle QEJ over here. And E is a common vertex for both the triangles. Now, let me consider the two interior angles in the bigger right triangle, that is interior angle at the vertex F and interior angle at the vertex E. And also consider two interior angles in the smaller right triangle. One is the interior angle at the vertex J and interior angle at the vertex E. So the two interior angles of the bigger right triangle are equal to the two interior angles of the smaller right triangle. Okay, now by angle similarity postulate, the two triangles are similar. Okay, now let me get the perimeter of the bigger right triangle. Once I get the perimeter of the bigger right triangle, I can get the perimeter of the smaller right triangle QEJ using the similarity concept. Okay, now to get the perimeter of the bigger right triangle DEF, we have to get the lengths of all the three sides. Already we have the length of for the side FE over here, that is 45. Now we have to get the lengths of the other two sides, DF and DE. Okay, here we can consider the information over here. That is the area of triangle DEF is 630 square units. Using this information, I'll be able to get the length of the side DF over here. Okay, first let me write this stuff over here. That is area of triangle DEF equals to 630 square units. And we have the formula for area of triangle, that is base times height divided by 2 equals to 630. Okay, in this triangle DEF, we can consider this one as base and this one as height. So the base of the triangle is 45. We can plug in 45 for B over here. And I do not know the height, that is the length of the line segment DF over here. For height, we can plug in DF. Let me write it over here. Divided by 2 equals to 630. Okay, now to solve for DF, we have to multiply both sides of the equation by the reciprocal of this fraction, that is 2 over 45. Okay, now let me do the same thing on the right side. Okay, here this 2 will cancel out, 45 will cancel out. I am getting DF on the left side. Okay, when I simplify this stuff, I am getting 28. Okay, here I got the length of the side DF. Okay, here DEF is a right triangle. So, and also D is a hypotenuse because it is opposite to the right angle. We can use Pythagorean theorem to find the length of the hypotenuse at DE. So, according to the Pythagorean theorem, the square of the hypotenuse equals to sum of the squares of other two legs. So, that is DF square positive FE square. Let me write it over here. Okay, DE square equals to, for DF, just now we got the length, that is 28. Let me plug in 28 for DF, then we get 28 square. And for FE, already we have the length, that is 45. We can plug in 45 for FE. Okay, DE square equals to, now let me calculate the value of 28 square. The value of 28 square is 784. Now let me calculate the value of 45 square. It is 2025. Let me write it over here. So D square equals to, okay, let me add 784 and 2025. When I add them, I am getting 2809. Let me write it over here. Okay, now to get the exponent 2 over here, I have to take square root on both sides. On the left side, the square root and square will cancel out. Usually, when we take square root on both sides of an equation, one of the square roots will cancel out. And for other square root, we will consider positive or negative sign. But here on the left side, we have DE. It represents the length of one of the sides of the triangle. It cannot be negative. So instead of positive or negative sign, we can just consider only positive sign over here on the right side. Then we get DE equals to, okay, now let me get the square root of 2809. That is 53. Okay, here I got the length of the hypotenuse of the bigger right triangle D, that is 53. Okay, now we have the lengths for all the three sides of the bigger right triangle DEF. Okay, now let's find the perimeter. That is the perimeter of the bigger right triangle DEF equals to the sum of the lengths of all the three sides of 45, positive 28, positive 53. When we add these three values, I am getting 126. The perimeter of the bigger right triangle DEF is 126. Okay, now let me erase this stuff and write the similarity statement for the two right triangles. First, let me take a vertex from the smaller right triangle QEJ. So that is J at where we have the right angle. Okay, now let me write the stuff over here, J. What is the corresponding vertex in the bigger right triangle? That is F, because at F we have right angle. Okay, now let me write it. And E is a common vertex for both the right triangles. So we can write E over here and E over here. The third vertex for the smaller right triangle is Q, and the third vertex for the bigger right triangle is D. Okay, already we have discussed by angle similarity postulate, these two triangles are similar. Okay, in the smaller right triangle, let me consider the side JE over here because we have the length for the side JE. Okay, now let me take the side JE from the smaller right triangle. What is the corresponding side in the bigger right triangle? So we have to consider the letters at the same position. Then we have FE. So JE and FE are the corresponding sides. The length of J is 21 and the length of F is 45. And also we can simplify this fraction. The greatest common divisor for 21 and 45 is 3. That is 3 goes into 21 7 times and 3 goes into 45 15 times. I am getting 7 over 15. Okay, here I got the ratio of the lengths of the corresponding sides of these two similar triangles, and that is 7 over 15. In whatever ratio we have the lengths of the corresponding sides, in the same ratio we'll have the perimeters of these two triangles. Okay, now let me write the perimeter of the smaller triangle JEQ, or it can also be written as QEJ. Let me write over here. And the perimeter of the bigger right triangle, that is DEF. Okay, so here the perimeters will be in the same ratio, that is 7 over 15. Okay, from the terms of the ratio over here, if I want to get the perimeters of the two triangles, I have to multiply both the terms by the same non-zero number, say x. That is, when I multiply this 7 by x, I'm getting 7x, and here when I multiply this 15 by x, I'm getting 15x. This 7x represents the perimeter of the smaller right triangle QEJ, and this 15x represents the perimeter of the bigger right triangle DEF. Already we got the perimeter of the bigger right triangle DEF in our previous working, that is 1 and 26. So this 15x and 1 and 26, both of them represent the same stuff, that is the perimeter of triangle DEF. So we can equate them, that is 15x equals to 1 and 26. Now let's solve for x in this equation. Let me divide both sides by 15. Then this 15 will cancel out. I am getting x equals to, when I divide 1 and 26 by 15, I am getting 8.4. Okay, here I got the value of x, that is 8.4. Now I can plug in this value 8.4 for x over here to get the perimeter of the smaller triangle QEJ. Okay, now let me do it. That is 7 times 8.4. Okay, when I multiply this 7 and 8.4, I am getting 58.8. Therefore, the perimeter of triangle QEJ is 58.8 units. The equation below is true for all values of x, where x is not equal to 5 over a and x is not equal to negative 3b over 2. The numbers a and b are constants. What is the value of b over a? Okay, now let me consider the equation we have over here. On the left side, we have subtraction of two fractions with the different denominators. We can simplify the stuff on the left side using cross multiplication method. That is, we have to multiply the first numerator by the second denominator and the second numerator by the first denominator. Further, we have to multiply the two denominators. Okay, now let me do it. That is 3x times 2x positive 3b negative 7 times ax negative 5, and we have to multiply the two denominators, that is ax negative 5 times 2x positive 3b. On the right side we have 6x square positive 5x positive a positive b divided by ax negative 5 times 2x positive 3b. Here we find the same denominator on both sides of this equation. Now to get rid of the denominators on both sides, we have to multiply both sides of the equation by the stuff we have over here. Then this one and this one will cancel out. Then the resulting equation is 3x times 2x positive 3b negative 7 times ax negative 5 equals to 6x square positive 5x positive a positive b. Okay, now let's do some more simplification on the left side. We can distribute this 3x to this one and this one. 3x times 2x is 6x square positive 3x times 3b is 9bx negative 7 times ax is negative 7ax and negative times negative is positive. 7 times 5 is 35 equals to 6x square positive 5x positive a positive b. We find 6x square on both sides of the equation. Let me subtract 6x square from both sides to get of the term 6x square on both sides of this equation. So here the positive 6x square, negative 6x square will cancel out. The same here. The resulting equation is 9bx and negative 7ax positive 35 equals to 5x positive a positive b. Okay, now let me continue over here. From these two terms, we can factor x out because we find x in common. Okay, now let me factor x out. Then I'm getting 9b negative 7a times x positive 35 equals to 5x positive a positive b. Here we have a linear expression on the left side and a linear expression on the right side. This is a x term and this is a constant term. Here this is a x term, and we have to consider this a positive b as a constant term because there is an information, there is a and b are a constants. Okay, here we have two linear expressions are equal. Whenever two expressions are equal, we can match the coefficients of like terms. That is, the coefficient of x on the left side, the coefficient of x on the right side must be equal. The constant term on the left side, the constant term on the right side must be equal. Then I am getting 9b negative 7a equals to 5 and 35 equals to a positive b. Now we can solve for a or b in this equation. Okay, now let me solve for b in this equation. Subtract a from both sides. Then this positive a, negative a will cancel out. I am getting 35 negative a equals to b. Okay, here I have solved for b in terms of a. Now what we can do is we can plug in this stuff 35 negative a for b over here in this equation. Then I am getting 9 times 35 negative a negative 7a equals to 5. Now let's solve for a in this equation. Let's distribute this 9 to 35. 9 times 35 is 315. 9 times negative a is negative 9a. Negative 7a equals to 5. 315. When I combine these two terms, I am getting negative 16a equals to 5. Let me subtract 315 from both sides of this equation. Let me do it. Then the positive value, negative value will cancel out. I am getting negative 16a equals to negative 310 on the right side. Okay, now let me divide both sides of this equation by negative 16. The negative 16 will cancel out. Here negative will cancel out. And for 310 and 16, we have the greatest common divisor 2. 2 goes into 16 8 times and 2 goes into 310 155 times. Okay, here I got the value of a, that is 155 over 8. Now let me plug in this value for a over here to get the value of b. Okay, let me do it. That is 35 negative 155 over 8 equals to b. Here we do subtraction between an integer and a fraction. Whenever I want to do addition or subtraction between an integer and a fraction, I have to multiply this integer 35 by the denominator of the fraction. Once I am done with this multiplication, I can take this 8 as a common denominator. Okay, 35 times 8 is 280, negative 155. Now we can take 8 as a common denominator. On the right side we have b. When I simplify this one, I am getting 125. That is 125 over 8 equals to b. Okay, here we got the values of the constants a and b. Our aim is to get the value of b over a. Okay, now let me erase the stuff and find the value of b over a. b over a equals to, for b we can plug in this value, that is 125 over 8, and for a we can plug in this value 155 over 8. Okay, now we can write this fraction as it is, that is 125 over 8. We can change this division as multiplication and get the reciprocal for this fraction, that is times 8 over 155. Okay, here 8 goes into 8 one times, 8 goes into 8 one times, and here for 125 and 155 we have the greatest common divisor 5. That is 5 goes into 125 25 times and 5 goes into 155 31 times. Okay, 25 times 1 we get 25 in numerator. In denominator we have 1 times 31, that is 31. Okay, here I got the value of b over a, that is 25 over 31. Y positive k equals to x positive 26, y negative k equals to x square negative 5x. In the given system of equations, k is a constant. The equation has exactly one real solution. What is the value of k? Okay, now first step, what we can do is that we can solve for y in each of the given two equations. Okay, to solve for y in the first equation, we have to get rid of this positive k. For that, we have to subtract k from both sides of this equation. Then I'm getting y equals to x positive 26 negative k. Now to solve for y in the second equation, we have to get rid of this negative k on the left side. For that, we have to add k to both sides of this equation. Then I'm getting y equals to x square negative 5x positive k. Okay, here I have solved for y in each of the given two equations. Now let's solve these two equations over here by equating these two y's. Okay, now let me write over here, that is y equals to y. For the y on the left side, let me consider this stuff in the second equation. Let me write it over here, that is x square negative 5x positive k equals to, for y on the right side, let me consider the stuff in the first equation, that is x positive 26 negative k. Here we have a quadratic equation in the variable y. Now let's write this quadratic equation in standard form. That is in the form ax square positive bx positive c equals to 0. So this is standard form of a quadratic equation. That is writing everything on one side of the equation, 0 on the other side of the equation. Okay, now in this quadratic equation, I am going to make the right side 0. For that, we have to get off all the three terms over here. Let me subtract x from both sides of the equation. Let me add k to both sides of this equation, and also subtract 26 from both sides of this equation. Okay, then this positive x, negative x will cancel out. Positive 26, negative 26 will cancel out. Negative k, positive k will cancel out. Here we get x square. When I combine negative 5x and negative 1x, I am getting negative 6x. When I combine positive k and positive k, I am getting positive 2k, negative 26 equals to 0. Okay, here I got the quadratic equation in standard form. Okay, now let me consider the quadratic equation in standard form, that is ax square positive bx positive c equals to 0. When the quadratic equation is given in standard form, and if this equation has only one real solution, then the value of the discriminant b square negative 4ac equals to 0. Okay, here for this quadratic equation, we have only one real solution, because the question says the given system has only one solution. We got this quadratic equation by solving the given system. So this quadratic equation will have only one real solution. So the discriminant, the value of b square negative 4ac must be equal to 0 for this quadratic equation. Okay, now to get the value of b, we have to consider the coefficient of x. Here the coefficient of x is negative 6. So for b square, we have to write negative 6 the whole square, negative 4 times. To get the value of a, we have to consider the coefficient of x square. Here the coefficient of x square is 1. Let me plug in 1 for a. And to get the value of c, we have to consider the constant term. Here 2k negative 26 is a constant term. We have to plug in this one for c. Okay, let me write over here, equals to 0. Now let's solve for k in this equation. The evaluation of this negative 6 whole square is 36. Negative 4 times 1 is 4 times 2k negative 26 equals to 0. Okay, now let me continue over here. 36. We can distribute this negative 4 to this one and this one. Then I'm getting negative 8k. Negative times negative will be positive. 4 times 26 is 104 equals to 0. Okay, negative 8k. When I combine 36 and positive 104, I'm getting positive 140 equals to 0. Now let me subtract 140 from both sides of the equation. Then this positive value and negative value will cancel out. Then I'm getting negative 8k equals to negative 140. Let me divide both sides of the equation by negative 8. Then this negative 8 will cancel out. This negative will cancel out. I'm getting k on the left side. On the right side, when I divide 140 by 8, I'm getting 17.5. Here I got the value of k. It is 17.5. The scatter plot shows a relationship between two variables x and y. A line of best fit is also shown. For what fraction of the data points in the scatter plot is a y value predicted by the line of best fit less than the actual y value? Okay, now let's count the number of data points we have above the line of best fit. That is 1, 2, 3, 4, 5, 6, 7. There are 7 data points above the line of best fit. Okay, now let's count the number of data points below the line of best fit. 2 positive 3 is 5, 6, 7, 8, 9, 10. There are 10 data points below the line of best fit. Okay, then the total number of data points in the scatter plot is 7 positive 10, that is 17. Okay, now in these 17 total points, we have to find the number of points where the predicted y value is less than the actual y value. Okay, let me write the stuff over here. That is, the predicted y value must be less than the actual y value. In other way, we can write this inequality as the actual y value has to be greater than the predicted y value. Both the inequalities represent the same stuff. Okay, now we have to identify the points out of these 17 where the actual y value is greater than the predicted y value. It's very clear in the data points above the line of best fit. That is, in these 7 data points, the actual y value is greater than the predicted y value. So the required fraction is 7 over 17. That is 7 over 17 of the data points. The y value predicted by the line of best fit is less than the actual y value. Here we have a system of two linear equations. In the given system of equations, a and b are constants. A is greater than 0. The system has infinitely many solutions. What is the value of a negative b? Okay, before I start solving this problem, let me consider a system of two linear equations in standard form. that is a1x positive b1y equals to c1. Here we have a linear equation in standard form. We call this one as standard form because we have the x term and y term on one side of the equation, constant on the other side of the equation. Let me consider another linear equation in standard form, that is a2x positive b2y equals to c2. Okay, now let me get the ratio of the coefficients of x, that is a1 over a2, and the ratio of the coefficients of y, b1 over b2, the ratio of the constant terms, c1 over c2. Okay, here I got the ratios of the coefficients of x, coefficients of y, and constant terms. Okay, when we have a system of two linear equations in standard form and the system has infinitely many solutions, then all these ratios are equal. Now, what we have to do is we have to get both the linear equations over here in standard form. Before that, we should try to get rid of the fractions in both the equations, because when the fraction is not there, the calculation process will be easier. Okay, now let me get rid of the fractions in the first equation. For that, we have to find the least common multiple of the denominators we have over here, 20, 15, and 20. So that is 60. When I multiply both sides of the first equation by 60, I can get rid of the three denominators. Then the fraction will be no more, and we can write the equation in standard form. Okay, now let me multiply both sides by 60. That is 60 times 9 over 20 times by positive 7 over 15 equals to 60 times negative 9 over 20 times ax. Okay, now we can distribute this 60 to this one and this one. Then I'm getting 60 times 9 over 20 times by positive 60 times 7 over 15. And here 20 goes into 21 times and 20 goes into 60 3 times. Then 3 times negative 9 is negative 27. That is negative 27 ax on the right side. Okay, here 20 goes into 21 times, 20 goes into 60 3 times. Here 15 goes into 15 1 times, 15 goes into 60 4 times. Here 3 times 9 is 27, that is 27 by positive. 4 times 7 is 28 equals to negative 27 ax. Now there is no fraction in this equation. Let's get this equation in standard form. Let me add 27ax to both sides of this equation, and also let me subtract 28 from both sides. When I do so, here this positive value, negative value will cancel out. This negative value, positive value will cancel out. I am getting 27ax positive 27 by equals to we have negative 28 on the right side. We have the first equation in standard form, that is we have x term and y term on one side of the equation. The constant is on the other side of the equation. Okay, now let's get rid of the fractions in the second equation. For that, we have to get the least common multiple of the denominators we have over here. Okay, first let me get the least common multiple for 8, 18, 2, and 12. Okay, here for all these four numbers, we have the greatest common divisor 2. So we can divide it by 2. When I divide 8 by 2, I am getting 4. Here 18 divided by 2 is 9. 2 divided by 2 is 1. And 12 divided by 2 is 6. Now there is no common divisor for all the four numbers over here. Even for three numbers, there is no common divisor. But we find common divisor for this 4 and 6, that is 2. Or we can consider the 9 and 6, for which we have the common divisor 3. Okay, now let me consider 9 and 6 for which I have the common divisor 3. Okay, now let me divide these numbers by 3. Actually, 4 is not divisible by 3, so we can write this 4 as it is. 9 divided by 3 is 3, and 1 is not divisible by 3, so we have to write this 1 as it is. 6 divided by 3 is 2. Okay, now in these four numbers, for these two numbers, we have the common divisor 2, so we can divide it by 2. 4 divided by 2 is 2. 3 is not divisible by 2, we have to write this 3 as it is, and we have to write this 1 as it is. 2 divided by 2 is 1. Okay, now no common divisor for all the four numbers, and also for three numbers, and also for two numbers. Now we have to stop the process. We have to multiply these numbers. 2 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 3 is 72. So 72 times 1 is 72, 72 times 1 is 72. So the least common multiple of these four denominators is 72. And now we have to multiply both sides of this equation by 72 to get rid of the denominators. Okay, let me do it. That is 72 times 1 over 8 times x positive 1 over 18 times y equals to 72 times a over 2 positive 5 over 12 times x. Okay, now let's distribute the 72 to the terms inside the parenthesis over here. Then I'm getting 72 times 1 over 8 times x positive 72 times 1 over 18 times y equals to, let's distribute this 72 to the terms inside the parenthesis over here. Then we get 72 times a over 2, positive 72 times 5 over 12 times x. Okay, now let's do some simplification. 8 goes into 8 1 times and 8 goes into 72 9 times. That is 9 times 1 is 9. 9 times x is we get 9x. Okay, here 18 goes into 18 1 times and 18 goes into 72 4 times. 4 times 1 is 4 and 4 times y is 4y. That is a positive 4y. And here 2 goes into 2 1 times and 2 goes into 72 36. That is we get 36a. And here 12 goes into 12 1 times and 12 goes into 72 6 times. 6 times 5x is 30x, positive 30x. There is no fraction in this equation. Now let's get this equation in standard form. Let me subtract 30x from both sides of this equation. Then this positive 30x, negative 30x will cancel out. When I combine this positive 9x and negative 30x, I am getting negative 21x, then positive 4y. On the right side, we have 36a. Here I got the second equation in standard form. That is x term and y term on one side of the equation, constant on the other side of the equation. Okay, now let me erase the stuff and continue the problem. Here we have the given equations in standard form. Now let me get the ratio of the coefficients of x. That is 27a divided by negative 21. The ratio of the coefficients of y, that is 27b divided by 4. The ratio of the constant terms, negative 28 divided by 36a. Here we have an information, the system has infinitely many solutions. Since a given system has infinitely many solutions, the three ratios that we got over here must be equal according to the stuff we have discussed over here. Okay, now let's do some simplification in the first ratio and third ratio here. And for 27 and 21, the greatest common divisor is 3. That is 3 goes into 27 9 times and 3 goes into 21 7 times. Here there is a common divisor, greatest common divisor for 28 and 36, that is 4. 4 goes into 28 7 times and 4 goes into 36 and 9 times. We get 9a over negative 7. And here we have to write this one as it is. There is a 27b over 4 equals to negative 7 over. We have 9a in denominator. Okay, here we have three ratios are equal. Since three ratios are equal, we can equate any two out of these three ratios. Let me equate the first ratio and the third ratio, because in the first one and third one we have a. By equating the first and third ratios, we will be able to solve for a. Okay, now let me equate the first one and third one. That is 9a divided by negative 7 equals to negative 7 over 9a. Now we can do cross multiplication. That is, this 9a has to be multiplied by this 9a. 9a times 9a is 81a square. We have to multiply this negative 7 by this negative 7. Negative times negative will become positive. 7 times 7 is 49. Now let me divide both sides of the equation by 81. Then this 81 will cancel out. I am getting a square equals to 49 over 81. Okay, now to get the value of a, we have to get of this exponent 2. For that, I am taking square root on both sides of the equation. Here the square root and square will cancel out. Usually when we take square root on both sides of an equation, one of the square roots will cancel out, and for the other square root we have to consider positive or negative sign. But here we have a on the left side, and the question says a is greater than 0. That is, a is positive. So here for this square root we can consider only positive sign, not positive or negative. So we have a on the left side. And when we take square root for a fraction, we have to find square root of the numerator and denominator separately. Square root of the numerator 49 is 7 and the square root of the denominator 81 is 9. Okay, here I got the value of a, that is a equals to 7 over 9. Now I can equate the first two ratios or the next two ratios to solve for b. Okay, now let me take the first two ratios. That is 9a over negative 7 equals to 27b over 4. Now to solve for b, we have to get rid of this fraction 27 over 4. For that, we have to multiply both sides of the equation by the reciprocal of this fraction, that is 4 over 27. Let me do it over here. 4 over 27. Okay, here this 27 will cancel out, 4 will cancel out, and here 9 goes into 9 one times and 9 goes into 27 three times. Here 4 times 1 is 4, 4 times a is 4a in numerator. In denominator, we have 3 times negative 7, that is negative 21 equals to, we have b on the right side. Okay, already we have the value of A, that is 7 over 9. We can plug in this value 7 over 9 for this A. Then I'm getting 4 times 7 over 9 over negative 21 equals to B. Okay, let me continue over here. 4 times 7 is 28 over 9 divided by negative 21 equals to B. To simplify this one, let's consider this negative 21 as a fraction by taking denominator 1. Now let me take this fraction as it is, that is 28 over 9, and change this division as multiplication and get reciprocal of this fraction. Then I'm getting negative 1 over 21 equals to B. Okay, here for this 28 and 21, the greatest common divisor is 7. That is 7 goes into 28 4 times and 7 goes into 21 3 times. 4 times negative 1 is negative 4, and 9 times 3 is 27. On the right side we have B. Okay, here I got the value of B. Okay, since we got the values for both the constants A and B, we can evaluate the value of this expression A negative B. Okay, now let me erase the stuff and continue the problem. A negative B equals to, for A we can plug in 7 over 9 negative. For B we have the value negative 4 over 27. Okay, 7 over 9 negative times negative is positive 4 over 27. Here we have addition of two fractions with different denominators. Okay, now to add these two fractions, we have to get the same denominator for both the fractions. In the second fraction, we have the denominator 27. In the first one, we have 9. Now, to make this denominator 9 as 27 in the first fraction, we have to multiply both numerator and denominator of the first fraction by 3. Okay, when I multiply this 7 by 3, I am getting 21. When I multiply the denominator 9 by 3, I am getting 27, positive 4 over 27. Okay, here I got the same denominator for both the fractions. We can take 27 as a common denominator. Now we can add the two numerators. I'm getting 21 positive 4. Okay, here when I add 21 and 4, I am getting 25 in denominator 27. Okay, here I got the value of the expression A negative B, that is 25 over 27. P equals to V squared divided by R. The equation above gives the power in an electrical circuit P in watts a function of the voltage V in volts and the resistance R in ohms. An electrical engineer is measuring two circuits. The first circuit has a voltage of V volts and a resistance of R ohms. The second circuit has a voltage of 12 V volts and a resistance of 3 R ohms. The numbers V and R are positive constants. Which of the following could represent the ratio of the power in the second circuit to the power in the first circuit? Here we have an equation that can be used to find the power in circuits. Here this capital P represents the power. Okay, now first let's find the power in the first circuit. For that we have to consider the voltage and resistance in the first circuit. It is over here. The voltage in the first circuit is lowercase v, and the resistance in the first circuit is lowercase r. To get the power in the first circuit, we have to plug in this lowercase v for this capital V and this lowercase r for this capital R. Okay, now let me get the power in the first circuit. That is a P1 equals to lowercase v square divided by lowercase r. Okay, now let's get the power in the second circuit, that is P2, and we have the voltage in the second circuit, that is 12V, and the resistance that is 3R. We have to plug in this 12V for this capital V and this 3R for capital R. Then I'm getting 12V the whole square divided by 3R. We can write this 12V the whole square as 12V times 12V divided by 3R. 3 goes into 3 1 times and 3 goes into 12 4 times. 4 times 12 is 48. And V times V is V square divided by R. Okay, here I got the powers in both the circuits. There is a power in the first circuit and power in the second circuit. Okay, according to the question, we have to find the ratio of the power in the second circuit to the power in the first circuit. Okay, power in the second circuit over power in the first circuit. It represents the ratio of the powers in the circuit 1 and circuit 2. Okay, here for P2 we got the stuff that is 48 V square over R. We can plug in this for P2, then we get 48 V square over R. And for P1 we have the stuff over here that is V square over R. Okay, now we can write this fraction as it is, that is 48 V square over R. And we can change this division as multiplication R over V square. This V square will cancel out, and here R will cancel out. I am getting 48 over 1. Here I got the ratio of the power in the second circuit and the power in the first circuit, that is 48 over 1. or it can be said as 48 to 1. We find 48 to 1 in answer choice C. The correct answer choice for this question is C. Point Q is the center of the circle. Point A, point B, and point C all lie on the circle. Point D lies on segment AC as shown. Segment BD is perpendicular to segment AC. In the figure shown, AB equals to 58 and AD equals to 40. If a point within the figure is selected at random, what is the probability that the point is within the shaded region? Express your answer as a decimal or fraction, not as a percent. Round your answer to the nearest and thousandth. Okay, here we select a point at random within the given figure. Actually, the given figure is a circle. Since a point is selected at random within the circle, the area of the circle should be considered as a sample space. The area of the circle should be written in a denominator. And in numerator, we have to write the stuff for which we have to find the probability. Actually, they are asking us to find the probability that the point is going to be within the shaded region. Then we have to write the area of the shaded region in numerator. So to get the required probability, we have to write the area of the given figure, that is area of the circle in denominator and area of the shaded region in numerator. Okay, we can get the area of the circle using the formula pi r square. So we need the radius of the circle. Once we get the radius of the circle, we can get the area of the circle. Okay, how do you have to get the area of the shaded region over here? For that, we have to find the area of the triangle we have over here. We have to subtract the area of the triangle from the area of the circle to get the area of the shaded region. Okay, now let's mark the given information. We have AB equals to 58. Here we have the line segment AB, its length is 58 and the length of AD is 40. Let me mark it over here. And also the line segment BD is perpendicular to AC. Here we have BD, it's perpendicular to AC. So we have right angle over here. Now, let me consider the line segment AC over here. Actually, it is a chord and this chord is passing through the center of the circle. In a circle, if there is a chord passing through the center, then the chord is the diameter. So this line segment AC over here represents the diameter of the circle. Then this is semicircle and this semicircle subtends an angle at point B on the circle over here. Okay, whenever a semicircle subtends an angle at any point on the circle, then it has to be a right angle. So here we have right angle at the point B on the circle. Clearly, this ABC is a right triangle. Then this side AC represents the hypotenuse of the triangle because it is opposite to the right angle. In a right triangle, apart from the hypotenuse, when I consider the remaining two legs, one of the legs should be taken as the base of the triangle and the other leg should be considered as the height of the triangle. Then we can use a formula base times height divided by 2 to get area of the triangle. Okay, now in this right triangle ABC, since AC is hypotenuse, we have to consider the remaining two legs AB and BC as the base and the height of the triangle. Then we can use a formula to get area of this triangle. Already we have the length for the leg AB over here. Still we have to get the length of the leg BC over here. Then we can get the area of this triangle. And also we have to get the length of the diameter AC. Once we get the length of the diameter AC, we can divide it by 2 to get the radius. Once we get the radius, we can find the area of the circle. Okay, now our aim is to get the length of the leg BC of the triangle and also the length of the diameter AC. How do we have to do? Okay, for that we can use a similar triangles concept over here. Now let me consider two right triangles. One is the smaller right triangle ABD over here and the other one is a bigger right triangle ABC over here. Okay, A is the common vertex for both the triangles. Now let me consider two interior angles in the smaller right triangle, that is A and D, and two interior angles in the bigger right triangle A and B. The two interior angles of the smaller right triangle are equal to the two interior angles of the bigger right triangle. Then by angle similarity postulate, these two right triangles are similar. Okay, then we can equate the ratios of the corresponding sides and we will get a chance to get the length of the diameter AC or the side of the triangle and the length of the leg BC of the triangle. Okay, let me write the similarity statement. Let me take a vertex from the smaller right triangle ABD over here. That is a vertex A and it is a common vertex for both the triangles. Okay, so vertex A in the smaller right triangle and vertex A in the bigger right triangle. Let me consider the vertex D at where we have right angle in the smaller triangle, and the corresponding vertex in the bigger right triangle is B, because at where we have the right angle. Let me write over here. The third vertex in the smaller right triangle is B, and the third vertex in the bigger right triangle is C. Okay, by angle similarity postulate, these two triangles are similar. Okay, now let me take the side AD in the first triangle, that is smaller right triangle. The corresponding side in the bigger right triangle is AB. Okay, here I got the ratio of one pair of corresponding sides. Let me consider the second side DB of the smaller right triangle. The corresponding side is BC in the bigger right triangle. Let me take the side AB in the smaller right triangle. The corresponding side is AC in the bigger right triangle. Since these two triangles are similar, the ratios of the corresponding sides must be equal. That is, the corresponding sides are proportional. Now let's plug in the known lengths over here. For AD, we have the length of 40. Okay, let me plug in 40. And for AB, we have the length of 58. And for DB, I don't have the length, but we can get the length of this line segment DB over here, because it's one of the sides of the smaller right triangle ABD over here. And we know the lengths of the other two sides. We can use Pythagorean theorem to get the length of this line segment DB. Okay, now let me write a Pythagorean theorem in the smaller right triangle. That is DB square positive AD square equals to AB square. Okay, in this smaller right triangle, AB is the hypotenuse because it is opposite to the right angle. When I take a sum of the squares of two legs, it must be equal to the square of the hypotenuse, that is AB square. Okay, I do not know the length of DB. Let me keep this DB square as it is. And for AD, I have the length, that is 40. Let me plug in 40 for AD over here, that is 40 square. And for AB, we have 58, that is 58 square. Then we get DB square. When I evaluate the value of this 40 square, I am getting 1600. Okay, now let me evaluate the value of this 58 square. It is 3364. Okay, let me subtract 1600 from both sides. When I do so, this positive and negative value will cancel out. I am getting dB square equals to, okay, let me evaluate the value of 3364 negative 1600. When I do so, I am getting 1764 on the right side. Let me write it over here. Now to get rid of the exponent 2 over here, I am taking square root on both sides of this equation. On the left side, this square root and square will cancel out. Usually when we take square root on both sides of an equation, one of the square roots will cancel out, and for the other square root, we have to consider positive or negative sign. Here on the left side, we have dB, which represents the length of one of the sides of the triangle. It cannot be negative. So here we don't have to consider positive or negative sign. We can consider this value as positive. Okay, here we have dB on the left side. On the right side, okay, now let me get the value of square root of 1764. That is 42. Okay, here I got the length of the side dB of the triangle, smaller right triangle, that is 42. Okay, now let me plug in this 42 for dB over here, 42 divided by, and for BC, I do not know the length, so I have to write this BC as it is. And for AB, I have the length, that is 58. Let me plug in. And for AC, I do not know the length. I have to write AC as it is. Okay, now three ratios are equal. Since all the three ratios are equal, we can equate any two out of these three ratios. And when I consider the first ratio, both the quantities are known, 40 and 58. When I equate the first ratio and the second ratio, I can solve for the length of the side BC of the triangle. Okay, now let me equate the first and second ratios. Then I'm getting 40 over 58 equals to 42 over BC. Now let's do cross multiplication. Then I'm getting 40 times BC equals to 42 times 58. Okay, let me divide both sides of this equation by 40 to solve for the length of BC. Here 40 will cancel out. Okay, now let me evaluate the value of 42 times 58, which is 2436. It has to be divided by 40. Then I'm getting 60.9. That is the length of BC is 60.9. Okay, now let me equate the first ratio and third ratio to get the length of AC. Okay, now let me do it. That is 40 over 58 equals to 58 over AC. Let's do cross multiplication. Then I'm getting 40 times AC equals to 58 times 58. Now I divide both sides of the equation by 40. Okay, here this 40 will cancel out. I am getting AC on the left side. Okay, now let me evaluate the value on the right side. That is 58 times 58. That is 3364. It has to be divided by 40. Then I'm getting 84.1. Okay, let me write over here. Okay, here I got the length of the diameter, that is 84.1, and also I have the length of the leg BC of the right triangle ABC, that is 60.9. Now, to get the radius of the circle, what we have to do is we have to divide the length of the diameter AC by 2, that is 84.1 divided by 2, then R equals to, okay, let me do it, 84.1 by 2, I am getting 42.05. Let me write it. Okay, here I got the radius of the circle. Okay, here we have all the information to get the area of the circle and also to get the area of the bigger right triangle ABC over here. Now let me erase this stuff and continue the problem. Let's get the area of the circle. Okay, let me write the stuff over here. That is the area of circle. The formula is pi r square. Already we got the radius, that is 42.05. Let me plug in this value for r over here. Then I'm getting pi times 42.05 the whole square. When I evaluate the value of this one, 42.05 the whole square, I'm getting 1768.2025, and we can write this pi over here. Now let me get the area of the bigger right triangle, that is the area of a triangle ABC equals to the formula's base times height divided by 2. Already we know that this AC is the hypotenuse of this bigger right triangle because it is opposite to the right angle. Okay, when I consider the remaining two legs AB and BC, we have to consider one of the legs as the base and the other leg as the height. Okay, when I consider this leg AB as the base, then we have the length 58 for the base. Let me plug in this 58 for the base B over here. And when I consider this leg BC as a height, we have 60.9 as height. We can plug in the 60.9 for height H over here. Then I'm getting times 60.9 divided by 2. Okay, using calculator, when I evaluate the value of this one, I am getting a 1766.1. Okay, here I got the area of the circle and the area of the triangle ABC over here. Now let me get the area of the shaded region. Let me write the stuff over here. Area of the shaded region. Okay, let me finish writing. Okay, to get the area of the shaded region, we have to subtract the area of this triangle ABC from the area of the circle. Then I'm getting 1768.2025 pi. That is area of circle, negative area of the triangle 1766.1. Okay, here I got the area of the shaded region. Now let's go to the question. If a point within the figure is selected at random, what is the probability that the point is within the shaded region? Since a point is selected within the figure, that is the circle, we have to consider the area of the circle as sample space to get the required probability, and the area of the circle, that is the sample space, should be written in denominator. Okay, now let me write the stuff over here. Okay, to get the required probability, we have to write the sample space in denominator, that is the area of the given figure or area of the circle. We got it already, that is 1768.2025 pi. In numerator, we have to write the stuff for which we need the probability. We have to find the probability that the point is within the shaded region. So we have to write the area of the shaded region in numerator. Already we got that. Let me write this stuff for here in numerator. That is 1768.2025 pi negative 1766.1. Okay, we can use Desmos graphing calculator to evaluate the value of this expression. Let's go to Desmos. Here we have Desmos graphing calculator. Okay, now let's evaluate the value of this expression. Let me give this expression as input over here. That is 1768.2025 pi negative 1766.1 divided by 1768.2025 pi. Okay, here I got the value of the expression, that is 0.682068. It keeps going. According to the instruction value, this value has to be rounded to the nearest thousand. When I round this value to the nearest thousand, I am getting 0.682. Therefore, the required probability is about 0.682. Hello students. I hope you would have understood all the 10 hard SAT math problems which have been explained so far. For more digital SAT math content, keep watching our YouTube channel. And also you can go to the URL over here to get more digital SAT math problems. Thank you.